So we're going to discuss integration by partial fractions. So when you get questions like this, 8x plus 1 upon x squared plus x minus 2 dx. Now the first thing you should check is, since we're given a function in the denominator, you must check, okay, do we have its derivative in the numerator? If you do, then that's equals to ln fx after integration. So let's see what's the derivative of x squared plus x minus 2. That's 2x plus x, 2x plus 1. So there's no way we can change this into 2x plus 1. So we don't have the derivative of fx in the numerator. So it's not this case. Then you must check, okay, can we do partial fractions of the given expression? Which we can. Yesterday we practiced that. Okay, x plus 1 in the denominator after middle term breaking, this becomes x plus 1, x plus 2, x minus 1. And we can break that into partial fractions using a upon x plus 2 plus b upon x minus 1. And we did solve this yesterday, and we got 5 over x plus 2 plus 3 over x minus 1. So I'm going to rewrite the fraction as 5 upon x plus 2 plus 3 upon x minus 1 dx. So we've broken the fraction into partial fractions. Now again, we have functions in the denominator. So we're going to check whether this case is applicable, where you have fx in the denominator, f prime x in the numerator, and when you integrate it, it's equals to ln fx plus c. So we do have x plus 2 in the denominator. The derivative of x plus 2 is 5. So what I'm going to do is take 5 outside, and I get 1 upon x plus 2 dx. And also take the integral of the, we're dividing the integral with the both expressions. We're writing the integral with the both expressions. So let me just do an additional step in case it confuses someone. So we're integrating this, and we're integrating this. So 5 can be written outside, and inside we get 1 over x plus 2. And 3 can be written outside, and inside we have 1 over x minus 1 dx. Now this is that case. There's the derivative of x plus 2, which is 1 in the numerator, and derivative of x minus 1, which is also 1 in the numerator. We do have the derivatives in the numerator, so it's going to be ln fx now. So 5 ln x plus 2 plus 3 ln x minus 1 plus c. Any questions? Another example. Integrate 2 minus x upon 1 plus x, 1 minus 2x. Okay. Again, we can break the given function into partial fractions. 2 minus x upon 1 plus x. 1 minus 2x can be written as a upon 1 plus x plus b upon 1 minus 2x. We solved this yesterday and we got 1 upon 1 plus x plus 1 over 1 minus 2x. So now we're integrating this. So again, split the integral. So we have a function in the denominator, fx. Check if we have f prime x in the numerator, then integration of this is ln fx plus c. So the derivative of 1 plus x is already 1. It's already here. So it's going to be ln 1 plus x. Then the derivative of this 1 minus 2x is actually minus 2, which isn't there, but we can multiply and divide with minus 2 here and here. So then we get minus half ln 1 minus 2x plus. Next case is case 6. Which is called integration as reverse of derivation. So no, we know that if we have A and if we derivate that and get B, that means we can integrate B and get A back. This is what it is meant by integration as reverse of derivation. So if you have A, you derivate it, you get B, then you can integrate B and get A back. So let's take a look at the examples. It usually comes in two parts. Questions on this topic. Part 1 is derivate e power 2 minus x squared. And part 2 is evaluate integration of 3x e 2 minus x squared dx. And also we're given the limits 1, 2, 3. That's the question. All right. 1, 2, 3. Okay. So first let's derivate the first part. So derivative of EFX is EFX times F prime X. So it's going to be E2 minus X squared times minus 2X. It's going to be minus 2X E2 minus X squared. Part 2 says, hence evaluate this. So what do we know from part 1? From part 1, we know that if we derivate e2 minus x square, we get minus 2x e2 minus x square. That means if we integrate that, if you integrate minus 2x e2 minus x square, you get e2 minus x square. So if derivation is this way, then integration goes backwards. That's why when you integrate minus 2x e power 2 minus x square, you should get e2 minus x square. Okay. So now the question was that we have to find integration of this 3x e2 minus x square. इसकी integration find करेंगे. So let's change this into that form. So what I'm going to do is I'm going to multiply both the sides with 3 upon minus 2. Let's see. We multiply both sides. Both sides of the equation gets multiplied with the constant, which is 3 upon minus 2 or minus 2 upon 3. Then what do we get? Minus 3 upon 2 integration of minus 2x e 2 minus x squared dx. And here we get minus 3 upon 2 e 2 minus x squared. Now notice here the 2 and 2 gets cancelled because you can bring out the 2. You can bring the 2 out of the integral sign. Minus 2 in fact. So then we'll be left with 3 integration x e2 minus x squared. You may send 3 inside the integral sign or keep it outside. It means it implies the same thing. And then answer is equals to minus 3 over 2 e2 minus x squared. कोई questions हैं तो please पूछो इधर. Okay, we also have to apply the limits. So the limits were 1, 2, 3. So we write 1, 3 here. So substitute 3 in place of x first, then substitute 1 in place of x, and then subtract the results. जो भी answer आएगा that would be the answer. It's minus 3 over 2 e2 minus 1 square minus bracket minus 3 over 2 e2 minus 1 square. Can you guys give me the answer? क्या आंसर आता है? 1 square is just 1. अच्छा sorry, that was 3. पहले हमने 3 सब्स्टिट्यूट करना है तो यहाँ पे 3 स्क्वायर होना चाहिए.
Uh, 4.07.
Sorry,
4.07.
हाँ सही है. That's correct. 4.07 or 4.08 is the answer with me. Do you get 4.08 after rounding?
Yes, ma'am.
All right. The next question. Part 1 is derivate tan 4x. Part 2 is hence find integration of 1 plus secant square 4x dx. So we do part 1 first, which is derivate tan 4x. So the derivation of tan fx is secant square fx upon f prime x. So this is what we get. Sorry, times f prime x. It's going to be 4 secant square 4x. I'm writing 4 over here. Part 2 says hence find integration of 1 plus secant square 4x. So the first thing I'll do is that I know that if I integrate 4 secant square 4x, I should get tan 4x. That is what I know from part 1. तो अगर इसको रिवर्स में लेके जाएंगे और इसको इंटीग्रेट करेंगे तो ओरिजिनल आंसर आएगा tan 4. Now what we have to do is find the integration of this. So let's attempt that here. I'm going to split the integral. So I'm going to get integration of 1 dx plus integration of secant square 4x. Since it says hence, so you must use the previous result in reverse. So integration of 1 is just x plus integration of secant 4x would be, इधर से निकालते हैं. It's first going to be 4 integration secant square 4x dx equals tan 4x, and then you can send 4 to the other side. Okay, so that gives us secant square 4x integration is tan 4x upon 4. Plus c. So again हमने concept use किया है कि integration is the reverse of differentiation. Another one. Find part 1 derivative of x ln x. Part 2 hence find integration of ln x. अब वैसे तो हमें इंटीग्रेशन ऑफ ln x नहीं आती. हमने जो रूल पढ़ा हुआ है वो डेरिवेशन ऑफ ln x पढ़ा हुआ है. डेरिवेशन ऑफ ln x is 1 upon x. So that's why you can't directly integrate ln. We haven't studied that. So we do it indirectly using part 1 first. So part 1 says derivate that, so it's a product, so we use the product rule of differentiation, which was if we're differentiating fg, then it's f prime times g plus f times g prime. So it's going to be 1 times ln x plus x times 1 upon x. So it's going to be ln x plus 1. Derivative of x ln x is ln x plus 1. For part 2, we're going to reverse this. हमें पता है कि इसकी derivation ये है. So that means इसकी integration ये है. So integration of ln x plus 1 should give us x ln x back. Okay. Split the integration of ln x plus, dx plus integration of 1 dx equals x ln x. इसको हम subject बना लेते हैं because this is what we have to find. So integration ln x dx plus integration of 1 is x equals x ln x. So again, we're making this the subject. So integration of ln x dx equals x ln x minus x plus c. Okay, one more example of the integration as reverse of derivation case. So d by dx ln x upon x square equals 1 minus 2 ln x upon x cubed. Part 2 is hence find integration of ln x upon x. Do part 1 first. We will be using the quotient rule of differentiation, which is if we're derivating a function f upon g, then that is equals to f prime g minus f g prime upon g square. Okay, so then we derivate ln x first, which gives us 1 upon x. X square gets multiplied, negative sign, ln x stays the same. X square gets derivated 2x upon square of x square, which is x power 4. So we get x minus 2x ln x upon x power 4 आ रहा है, ऊपर x power cube क्यों लिखा? ठीक है, क्योंकि x कॉमन लिया हुआ है उन्होंने और फिर डिनोमिनेटर से कैंसिल किया हुआ. Take x common 1 minus 2 ln x upon x power 4, which gives us the required form 1 minus 2 ln x upon x. Part 2. Hence find integration of ln x upon x cube. Okay. Hence means we have to reverse this. So when we integrate this, we get the original function back. So integration of 1 minus 2 ln x upon x cube equals to ln x upon x squared. Split the integration in with 1 upon x cube dx minus integration of 2 ln x upon x cube dx equals ln x upon x square. इसको तो हमें इंटीग्रेट करना आता है. First, I'm going to rewrite it as integration of x minus 3 dx. And here I'm going to bring out the minus 2. So inside we have ln x upon x cube, जिसको हमने basically subject बनाया, equals ln x upon x square. So integration of x minus 3, x power minus 3 is power gets added by 1, so minus 2 upon minus 2. Then minus 2 integration of ln x upon x cube dx equals ln x upon x squared. Okay, so this goes to the other side, gets added. So I'm writing, in fact, no, let's take this to the other side so that it becomes positive. So this would still be minus 1 upon 2x square. I've taken the negative index to the denominator ताकि positive हो जाए, नीचे चला गया. And minus ln x upon x square comes to this side, and we get 2 integration of ln x upon x cube dx. Now we have to find the value of this, so send 2 to the other side. So we get minus 1 by 4. X square minus ln x upon 2x square equals integration of ln x upon x cube dx. Let me confirm if that's fine. Yes, it is. कोई question है तो please पूछो. ये primarily add math में आता है, लेकिन A2 में एक क्वेश्चन ऐसा आया है एक साल. I think it was 2019 के 2020 में मैंने एक ऐसा क्वेश्चन दे दिया, इसीलिए अब इधर भी हम ये पढ़ाते हैं. वैसे ये एड मैथ का प्रॉपर टॉपिक है. मेरीन फजील कोई क्वेश्चन है तो बेटे बताओ.
नो मिस.
अगला हमारा टॉपिक है इंटीग्रेशन बाय सब्स्टिट्यूशन. वो काफी डिटेल टॉपिक है तो मैं अभी नहीं स्टार्ट करूंगी. और उसके बाद एक और डिटेल टॉपिक है इंटीग्रेशन बाय पार्ट्स, और उसके बाद हमारी इंटीग्रेशन खत्म हो जाएगी. सो इट्स 2 more lessons before we start the worksheet. कल इंशाल्लाह we will do half of the rest of integration इंशाल्लाह. So see you tomorrow. आज का होमवर्क है कि ये वाला जो अभी केस ये है ना, इंटीग्रेशन एज रिवर्स ऑफ डेरिवेशन, इसके हर क्वेश्चन को दोबारा से खुद से करो. मुझे देख के आपको 30-40% समझ आती है, इससे ज्यादा नहीं समझ आती. खुद करके फिर 70-80% समझ आती. ठीक है, सो प्लीज redo all these questions as homework. Take care. See you guys tomorrow, inshallah. Allah Hafiz.